Okay, ma? So the last topic of heat is thermodynamics, ma? So what is meant by thermodynamics? First of all, we will have an introduction. See, ma? So after this chapter is completed, we will understand one thing. What we understand is, okay, 100% of work can be converted into heat energy. Can be converted into heat energy. Okay, ma? So it is possible that total work which you do, you can convert that one into heat energy. Okay? But the problem is that 100% of heat energy cannot be converted into work. Cannot be converted into work. So definitely there will be some wastage of energy. Are you able to understand, ma? So this we will study, we will understand after completing this topic of thermodynamics. Are you able to understand? So 100% of work, how can you convert into energy? For example, if you have an electrical heater, in homes electrical heaters will be there, no, ma? Or water heater will be there, no? So we supply electrical energy to that. And total electrical energy will be converted into heat energy. So 100% conversion of energy into heat is possible. But heat energy 100% you cannot utilize into work done. Are you able to understand, ma? So the highest efficient heat engine has an efficiency of only 50%. Okay, ma? What is meant by heat engine? It converts heat energy into work done. Okay, ma? And the engine which is having highest energy of all the heat engines, that is having an efficiency of only 50%. It means 50% of heat you can convert it into work, and remaining 50% must be wasted. That is, that remaining 50%, it will be released into the atmosphere. Are you able to understand? This is one point. So next we study about state variables. Okay, ma? So pressure, temperature, volume, and internal energy, they are called as state variables. Okay, ma? So they depend only on initial state and final state. They are not dependent on how you are heating the gas. That doesn't depend upon. They depend only on what is the initial state, what is the final state. That is why they are called as state variables. Okay, ma? So does not depend on path taken. Okay, ma? What is the path in which we are heating the gas? That doesn't depend on that. So that depends on what? Depends only on initial and final states. Okay, ma? They depend only on initial state of the gas and final state of the gas. Understood, ma? Okay. Then we have path functions, ma? Path functions. What is meant by path functions? They depend only on the path in which we are heating the gas. There are many types of processes, no? Isothermal process, adiabatic process, isochoric process. All these are different processes in which we can heat a gas or cool a gas. So they depend on the process in which we are heating the gas. And what are they? They are heat supplied, and work done. Okay, ma? So heat is supplied and work done, they are path functions. So how much heat we are supplying and how much work is done, that depends on purely the process in which we are heating this gas or cooling this gas. Understood, Nama? Okay? Make a note up to here. So then we will study each of these processes in detail, ma? But before that, we will study the types of walls which system can have. Okay? So types of walls system can have. Already we have studied in chemistry also, know how many types of walls can be present. Two types of walls. One is adiabatic wall, second one is diathermic wall. Okay, ma? First wall is diathermic, second one is called as adiabatic wall. Okay, ma? Diathermic wall means it can transfer heat energy. It can transfer heat energy into the system or out of the system. Okay, ma? That is called as diathermic wall. Then what is meant by adiabatic wall? Adiabatic wall means it doesn't allow heat energy. It doesn't allow heat energy into the system or out of the system. That is called as adiabatic wall. So does not allow heat energy. Okay, ma? Into the system or out of the system. This is called as adiabatic wall. Okay, ma? So then we study about open system. Types of systems, open system. Okay, ma? So what is meant by open system? Open system means energy and mass both can be transferred. Okay, ma? I can transfer energy also, I can transfer mass also into the system or out of the system. That is called as open system. Then we study another system which is called closed system. Okay, ma? Closed system. So what is meant by closed system? Okay, ma? Here I can transfer only energy, mass cannot be transferred. Clear, ma? So only energy can be transferred. Okay, whereas mass cannot be transferred. This is called as a closed system. Understood, no? Then we have one more system which is called isolated system. Isolated system. Utta notes rasta unnara vinta unnaru kodra meeru vinta unnaru kada vintu rayandi. Okay, isolated system. Isolated system means what? You cannot transfer energy also, you cannot transfer mass also. Okay, ma? So neither energy nor mass can be transferred. Okay, ma? You cannot transfer energy also, you cannot transfer mass also. So this is the basic introduction about what you call the types of systems we have in thermodynamic processes. Okay, ma? So what is meant by state variables, path variables, then types of systems, types of walls, all this. Clear, Nama? That's it. Then after this, we will study about the different processes which can be done in the case of thermodynamics. Okay. Already we have studied in KTG and we have drawn graphs, Nama. So here again we will study each of them in detail. Okay. So, but before that, just we will have an introduction. Then in the later classes, we will have a detailed discussion on this one. So, types of processes. How many types of processes are there? First one is adiabatic process. Second one is isothermal. Isothermal process. Third one is, clear ma? Isochoric process. And the fourth one is called as isobaric process. So these are the different processes which we have in the case of thermodynamics. Okay, ma? Adiabatic process means energy cannot be transferred into the system or out of the system. Okay, so delta Q is equal to 0. Q means heat energy, no? Heat energy cannot enter into the system or out of the system. So because it wall, what kind of wall it will have? Adiabatic wall it will have. So if walls are adiabatic, heat energy cannot enter into the system or go out of the system. Isothermal means a change in temperature is 0, or you can say temperature is a constant. Okay, ma? Isochoric process means a change in volume is 0, or you can say volume is a constant. Clear, no? Isobaric process means a change in pressure is 0, or you can say pressure is a constant. So these are the different processes. Understood, no? We will study each of them after some time, but before that, first of all, we will study work done on the gas, work done by the gas. Okay, ma? Completed? Fine? Okay. So therefore, keep the next side heading, work done by the gas and on the gas. So these two you should understand very carefully, ma'am. Okay? Because in thermodynamics, mostly questions will be given on work done, ma'am. So work done is the most important concept in thermodynamics. Okay? So, work done by the gas and on the gas. In chemistry, we don't study by the gas, on the gas, we don't study. Okay? If energy is lost by the system, then that is taken negative in chemistry. Okay, if system is receiving anything, then that is taken positive in the case of chemistry. Okay? But in physics, we will deal according to the formula of physics. Okay? So now let us see. So consider this is a system. This is a piston inside which gas is present. Are you able to understand? So because of pressure inside this gas, what is happening? Sima, we know that pressure is equals to force per unit area. No? Pressure is equal to force per unit area. Pressure does not have any direction, no direction. Pressure's direction is not considered. Okay, ma? Because pressure is applied on every side, so you cannot take a particular direction of pressure. But force always has a direction. Force is having direction because force is a vector quantity, pressure is a scalar quantity. Are you able to understand, ma? Now this gas always exerts pressure in which direction? Gas always exerts pressure perpendicular to the surface in contact. Okay, ma? Gas always exerts pressure, not pressure, ma? Force. Exerts force perpendicular to surface in contact. Okay? So whatever may be the surface for which this gas is in contact, it always exerts perpendicular force. Oh? So therefore, what is the direction of force exerted by this gas? If you take this side of this container, force will be in this direction. Okay? So, and on the base of the container, this is the direction of force. On this side, this is the direction of force. And on the piston, this is the direction of force. Understood, no? Are you able to understand? No? Because force is exerted by gas, in which direction? Always perpendicular to surface in contact, whatever surface. For example, even on human body also, air is exerting pressure in which, force in which direction? Perpendicular to the body surface. Okay? So on the top of the hand, force will be in this direction. Bottom of the hand, force will be in this direction. On this side, in this direction, like that. Always perpendicular. Okay? So therefore, what I see now, if I take this piston, okay, ma, this is the piston. So listen very carefully. Okay, ma. This is not like chemistry. Anything entering into the system is taken positive, leaving out of the system is negative. Anta easy we should study very carefully. Sima. So force on the piston is in this direction. So if a piston moves in upwards direction, it means the displacement is also in upward direction. So force and displacement, if both of them, if they are in the same direction, then work done by the gas will be positive. No? Okay, ma? Who is applying this force? Gas is applying. Piston is moving in which direction? Upward direction. So what is the work done by gas? Work done by the gas is Fs cos theta, no, ma? Force is F, displacement is S, cos 0. Cos 0 only, no? Because force and displacement, they are in the same direction. Cos 0 plus 1. So therefore, work done by the gas is considered positive. Okay? So in which condition you will consider work done by the gas is positive, ma? If piston moves in upwards direction. If piston moves in upwards direction, volume of the cylinder increases, no? So therefore, if volume increases, then also you can say work done by the gas is positive. Work done by the gas is positive. Okay? So therefore, what is the note point here? We have to write a note point is that if volume of gas increases, okay, ma? If volume of gas increases, then definitely I can say work done by the gas is positive. Understood, no? So piston should move upwards, or volume of the gas should increase. Then we can say work done by the gas is positive. Okay? Similarly, if I take one more condition, consider this is a piston. Okay, ma? gas is applying force in this direction. Okay, ma? But piston is coming downwards. Displacement is in downwards direction. Piston previously it was here, no ma? Piston is coming downwards into the gas. Okay. Then in that condition, what is theta value? Theta value is 180 degrees. Okay, ma? 180 degrees, because force is in this direction, displacement is in downwards direction. This angle is 180 degrees. Understood, no? So if angle is 180 degrees, what I can say, definitely work done is equal to Fs cos theta. And we are taking force applied by the gas, no? So this is also work done by the gas. Clear, no, ma? So work done by the gas is equals to Fs cos 180 degrees. So Fs cos 180 is minus 1. So work done by the gas is negative. Okay. So that is called as negative work done by the gas. Okay. So gas is applying force in upward direction, but piston is moving downwards. Are you able to understand? It means gas is compressed. No? If gas is compressed, then we can say work done by the gas is negative. So make a note of that point. So what is the note point I have to write? Note point is that, clear ma? If gas compresses, okay ma? If gas compresses, work done by the gas is negative. Work done by the gas is negative. Is it clear? Okay. So work done on the by the gas we have studied, no ma? Now what is meant by work done on the gas? Work done on the gas means what, ma? If somebody is applying force in this direction, this is force applied by external forces, no? So this force applied, it will be in exact opposite direction to the direction of force applied by the gas. Force, gas is applying force in this direction, no, on the piston. It is trying to push the piston upwards. But external force, it will try to compress piston. It will try to make the piston move downwards. Are you able to understand? So work done on the gas will have exactly opposite cases as that of work done by the gas, because force direction is opposite. No? Are you able to understand? So here we have written work done by the gas is positive. So definitely I can write work done on the gas is negative. Okay. Why on the gas is negative? Because force is in downwards direction. Force applied by external force, downwards direction. But piston is moving. Displacement is in upward direction. No? So angle is how much? Angle is cos 180. Okay. So therefore work done on the gas is negative. That's all. So therefore I write, if volume of gas increases, work done by the gas is positive, on the gas is negative. That's all. Force direction maripoyindi kada. So the symbol of work done also will change. Okay. Now see this condition. This is an example of compression. Okay, Nama? So what is happening? Force is in upward direction. Sorry, force is in which direction? F external force. External force is applying force in downwards direction. Work done, force applied by the gas is in upward direction. So therefore, work done on the gas. On the gas. So W is equals to Fs cos 0 plus 1 positive on the gas. That's all, no? Clear, no? So if gas compresses, work done by the gas is negative, work done on the gas is positive. Okay? So I will write work done on the gas is positive. In which condition? If gas compresses. That is, if volume reduces, I can say work done by the gas is negative, on the gas is positive. So first of all, up to here it is clear, Nama, what is meant by work done by the gas and work done on the gas. Okay? Just you remember, if gas expands, work done by the gas is positive. The remaining everything you can write. Work done on the gas is exactly negative. Okay? That's it. Okay, ma? So what is the note point I can write? Note point is that work done by the gas and work done on the gas will have always opposite sign conventions. Okay, ma? Always they will have opposite sign conventions. If work done by the gas is positive, on the gas will be negative. That's it. Okay? Make a note. Now see ma. So we will try to derive equation of work done in the case of by the gas or on the gas ma. Okay, see ma. What is the equation for work done? W is equal to Fs cos theta. This is the equation for work done ma. This is the equation for work done in terms of force and displacement. Okay. But in the case of this gas or volume of a gas, pressure and volume are more relatable, no? So instead of studying force applied by the gas, we study pressure of the gas. Instead of studying displacement of the piston, we study change in volume of the gas. Clear, no? So therefore, one more equation for work done is pressure into volume. So this is the equation for work done. Okay? Or we can write pressure multiplied by change in volume. This is the equation for work done. Okay, ma? So force per unit area is nothing but pressure, no ma? So if you multiply and divide by area, you will get pressure. So area multiplied by displacement is nothing but volume. That is the method of derivation. So this is another equation for work done. W is equal to pressure into change in volume. Okay, ma? Now this equation I can use in which condition? If pressure is a constant. Okay, ma? If pressure is a constant, I can use this relation. Work done is equals to pressure into change in volume. Are you able to understand? So if work done is variable, W is equals to integration of P dV, limits are applied from V1 to V2. So this is the equation of work done by the gas if pressure is a variable. Pressure is a variable. Are you able to understand, ma? So if pressure is a constant, directly you can use this relation. Pressure into change in volume. But if pressure is a variable, then I have to use integration, no? So W is equal to integration of P dV, limits are applied from V1 to V2. Work done by the gas. On the gas. Work done on the gas, ma? Come on. Negative of P dV or P delta V if force is a constant. So work done on the gas is negative of P dV. Limits are applied from V1 to V2. These are the equations. Understood, no? By the gas, on the gas. Just opposite symbols, that's it. Why we got opposite symbols already we have studied, no? Are you able to understand, ma? That's it. Okay, now see if I draw the one more point here we have to study. Clear, ma? Area under PV graph. Okay, we will study area under PV graph. See, ma. So work done is equals to P into delta V is just like area is equals to length into breadth, no ma? This format of the equation, it is just like this format, no? Area is equals to length into breadth. So therefore, if you take the area under pressure and change in volume, then you will get work done. That is the meaning of it. If you take the area under length into breadth, that is called area, no? Clear? Similarly, so area under PV graph gives what? Gives work done. So are you able to understand what is happening? Area under PV graph will give work done. Why? Because it is of the format of area is equals to length into breadth. In kinematics also we have studied, no? So displacement is equal to velocity into time. So if you take the area under velocity into time, what you will get? You will get displacement. Okay? Acceleration, velocity is equals to change in acceleration multiplied by time. Are you able to understand, ma? Or change in velocity is equal to acceleration into time. So you take the area under acceleration time graph, it will give velocity. Same concept here also. Everywhere you can use the same concept. Okay, ma? So whenever equation is of this format, you can compare with this one with area is equal to length into breadth. Is it clear? For example, if I draw one area, clear, ma? For example, consider this is the graph. So this is pressure and this is volume. Okay, ma? And consider graph is like this. Graph is like this. Okay. So when you look at this graph, what do you understand? Pressure is constant, volume is changing. Clear, no, ma? So let initial volume is V1, final volume is V2. So gas, is it increasing, volume is it increasing or decreasing? Volume is increasing because we are moving in this direction. Direction of arrows is very important, ma. Clear? We are moving from lower volume to higher volume. It means volume is definitely increasing. Okay? So therefore, if I want to calculate work done in this condition, can you say how can I calculate work done, ma? In this graph, I want to calculate work done. How can I calculate? What is the formula of work done? So P into delta V, integration of P dV. In both of them, which one I have to use? First one. Why can't I use second one? This equation is used only when pressure is a variable. But here pressure is a constant. So what is the relation I have to use? Work done by the gas is equals to P into delta V. So P multiplied by delta V is nothing but a final volume minus initial volume, no? So that is the equation for work done by the gas. Okay. Definitely V2 is greater than V1, no? Are you able to understand, ma? So therefore work done by the gas will be positive. Okay. Because this is expansion, no, ma? This is expansion. Because this is expansion, I can say work done by the gas will be positive. And work done on the gas, ma? Work done on the gas will be negative. Clear, no? That's it. Similarly, if I draw one more graph. Okay, ma? So, if I draw a graph like this. So, consider this is the graph. So, this is pressure and this is volume. Now, in this condition, how can I draw the graph? Sorry. How can I find out work done? First of all, work done is nothing but area under the graph. That's all, no? Find out area. Area is nothing but work done. Okay, but here also. In this condition also, just if you can find area, area is nothing but work done. But this is not a regular figure, no? We cannot find out the area of this one. So we have, if there is any equation of pressure, how pressure is changing, integrate that pressure with respect to volume, you will get work done. It means which equation I have to use? W is equal to integration of P delta. Limits are applied from V1 to V2, P dV. Okay, ma? So this will be our equation of work done if pressure is a variable. Okay. So here I can say pressure is a variable condition. Therefore, we have to use this graph here. Are you able to understand? Okay, ma? Clear, no? Okay. Now, by looking at the graphs, let us try to understand which graph is positive work done and which graph is negative work done. Okay. Now, see, this graph, volume increasing or decreasing? So, work done by the gas, on the gas, negative. What about this graph? You cannot explain whether volume is increasing or decreasing without direction. Only by giving direction only you can understand whether work done is positive or negative. If somebody gives the graph without direction, then you can never understand whether it is positive work done or negative work done. Directions are very important. They are called indicator diagrams. Okay, ma? And indicator diagrams, definitely direction must be mentioned. Now, final volume is, this is V2, this is V1. Which one is initial volume, which one is final volume? V2 is initial volume, V1 is final volume. Are you able to understand, ma? It means that definitely volume is reducing, no? Volume is reducing means work done by the gas will be negative. Work done on the gas will be positive. That is the meaning of it. Okay? Yes. Similarly, if I draw some more graphs. Okay, ma? For example, if I draw some cyclic graphs. Cyclic graphs means what? So I complete one complete cycle and I return to the same states once again. Okay, ma? Path may be same, path may be different. Okay, ma? If path is same, then it is called reversible. If path is not same, it is not called reversible. Okay, ma? Cyclic graphs means after completing the total cycle, again I have to reach to the same states. Okay, now see. For example, I will draw two types of graphs, ma. This is pressure and this is volume. Consider this is the graph which I have drawn. So A, B, so this is the shape of the graph. So I am starting from A, I am reaching up to B. Then again I am reaching up to A. So I am reaching to the same states, no? So definitely this is a cyclic graph. Okay. Now in this total graph, finally, am I doing positive work or negative work or zero work? So if I reach to the same states, can you say work done is zero? States are same. But work done doesn't depend upon states. Work done depends upon path. Starting lo ade kada manam raskundi. Only pressure, volume, temperature, internal energy, they are state functions. Okay, ma? If I am starting from here, here I can say pressure is P1, volume is V1, temperature is T1, internal energy is U1. Okay? And at point B, pressure is P2, volume is V2, temperature is T2, internal energy is U2. And if I reach to the again states, again P1, V1, T1, U1, they are satisfied. but energy and heat supplied, they are not satisfied. Okay, ma? So first make a note of that point once again. What is the note point here? We have to write note point is that. So if we reach to same states via a cyclic process, clear ma? Heat supplied, heat and work done will not be zero. They are not zero. Okay, ma? They depend on what? They depend on process. So let us see what is the process here. Okay, understood, no ma? Now see, this graph can be separated. This graph can be separated into two separate graphs. Okay, ma? What is the first graph? So this is pressure, this is volume. First graph is this one. And one more graph which I can draw is, this one. Okay. So this graph I can separate into two graphs, no ma? This graph and this graph. Topmost graph, bottommost graph. Now, how can I calculate area under this graph? Area under PV graph is nothing but work done, no ma? So how much is the area? This much is the area, no? Are you able to understand? Okay. So this much area is present inside this graph. Okay. Let us call this area as area A1. Okay, ma? So area A1. Now the question is, work done by the gas, is it positive or negative? Work done by the gas is positive or negative in this graph? Anybody? Positive. How can you say? Volume పెరిగింది కదా, ఏముందంత ఆలోచించడానికి అక్కడ. ఓకేమా? Initial volume is V1, final volume is V2. Volume has increased, no? If volume has increased, it means definitely area of the graph is positive. That is, work done by the gas is positive. So therefore I say work done by the gas is positive. Understood, no? Now go for the second graph. Okay. In the second graph, what is the area? This much is the area. Area under PV graph only, no? So therefore this much is the area. And I will call this area to be area A2. Okay. So work done by the gas is positive or negative? Definitely negative. Why negative? Because volume is decreasing. We are moving from higher volume to lower volume. So work done by the gas is negative. Or we can say A2 minus A2 or plus A2, anything. Are you able to understand? Okay, now see. Now can you say positive area is bigger or negative area is bigger? Area పెద్దదా, area A1 is bigger than A2 or A2 is bigger than A1? ఎలా చెప్తారు? అంటే కామన్ సెన్స్ యూస్ చేసి చెప్తారనమాట. సో డెఫినెట్లీ A1 is bigger than A2. It means positive work is greater than negative work. It means finally gas has done positive work. Okay, ma? Finally gas has done what kind of work? Positive work. That is the meaning of this. Are you able to understand? So therefore what we write? Therefore we write positive area is greater than negative area. Or you can say A1 is greater than A2. Okay, ma? Therefore what I can say? Where shall I write? Shall I rub this one? No, I cannot rub this one. So we will write here only. Therefore, work done is nothing but A1 minus A2 and it is positive. Okay. So therefore I can say work done by the gas is positive finally. Are you able to understand how to analyze? This is a cyclic graph. We are separating the graphs into two parts. So we are seeing work done in first graph whether it is positive or negative. Work done in second gas is positive or negative. Second process. Then we are seeing which area is greater. If positive area is greater, it means finally gas has done positive work. Are you able to understand, ma? Similarly, if negative area would have been greater, then work done by the gas is finally negative. Is it clear? Okay. Now see. So by doing all this, I got work done finally by the gas is positive. Now if you see this process, is this a cyclic graph or a clockwise graph or anti-clockwise graph? This is what kind of graph? Clockwise graph. No, clock will move in this direction only, no? So it means if a cyclic graph is a clockwise graph, then work done by the gas will be always positive. This is the most important point here. Are you able to understand? So write down. Okay, ma? So what is the final point we have to understand here? Note point is that, okay, ma? If cyclic process is clockwise, then work done by gas is positive. Okay, ma? Are you able to understand? And what is that work done? Work done is nothing but A1 minus A2, no, ma? A1 minus A2. Okay. And what is A1 minus A2? A1 minus A2 is nothing but area enclosed in this cyclic graph. Can I say like that? Is it correct, ma? This area is nothing but A1 minus A2. And this is nothing but work done. Final work done. See, ma, this, from this total area, if you remove this area, then what is the remaining area? Remaining area is this only. Are you able to understand? So just if you take the area enclosed under the cyclic graph, that area is nothing but final work done. It may be positive, it may be negative. If a graph is cyclic graph, work done by the gas is positive. If it is a cyclic graph and in anti-clockwise direction, then work done by the gas is negative. That's it. Are you able to understand? So therefore what we say, therefore, okay, ma? Area enclosed by cyclic graph is nothing but work done. Final work done. And when it is positive, when it is negative, already we have understood. No? That's it. Very simple. Okay, ma? So if you understand this total concept carefully, ma, then whatever may be the type of graph given, very easily you can calculate what is the amount of work done and whether it is positive or negative. That's it. Fine? Okay. Now I will give you one example. Can you try? Completed, no? So in the discussion on the work done, physics law. Chemistry law, okay, ma? So these are the graphs given and we are supposed to calculate the work done in these following processes. Clear, ma? So this is the first process. This is the type of graph which is given, ma? So the values of volume and the values of pressure they are given. So what is the work done in this condition? So work done, first of all, can you say work done by the gas, is it positive or negative? Positive. How can you say? Clockwise graph. Clockwise graph, no, ma? Because this is a clockwise graph, work done by the graph is positive. Are you able to understand? And how much will be the work done? Work done is nothing but area under the graph, no? Work done is nothing but area under the graph. What is the shape of this area? Triangle. So what is the area of a triangle? Half into base into height. So therefore I will write half into base into height. So half into, what is the base? Base is 4 minus 2, no? This is the length of the base. 4 minus 2. And what is the height? Height is 4 minus 2. This is also 4 minus 2. But the problem is here pressure is given in atmosphere. Atmosphere is not the SI system of measuring pressure. Newton per meter square is the SI unit. Or you can say Pascal. Newton per meter square, you can call it as Pascal also. So units I am writing here. 1 atmosphere is equals to 1.013 into 10 power 5 Newton per meter square. Or simply you can write Pascal. PM means Pascal. Okay. So therefore, value how can I write? 4 minus 2 multiplied by. Now I have to multiply by 10 power 5 norma. 1.01 is negligible. So in a very big calculations, you need not write 1.01. Just you can write 10 power 5. Okay. But if calculations are very small, then definitely you have to use. So 10 power 5. So if you do this calculation, you will get the amount of work done in terms of joules. Okay. So 4 minus 2 is 2, norma. So and 2 and 2 get cancelled. So therefore how much I got? 2 into 10 power 5 joules. So this is the amount of work done. 2 into 10 power 5 joules. And it is positive work. Gas has done positive work in this condition. Or I can say work done on the gas is negative. Okay. In same condition I can write work done on the gas is how much? It is minus 2 into 10 power 5 joules. This is how I can calculate. Are you able to understand? Okay. Now see. Now how can I calculate area in the case of this condition in second question? Okay, ma? See ma here. First of all, work done by the gas is positive or negative? Negative. Negative. Why? Anti-clockwise graph. So work done by the gas is negative. Understood, no? And what is the shape of the figure? Pi r square, circle. So, circle means formula of area pi r square. What is the radius? Radius is how much? We don't know. Are you able to understand, ma? So, therefore, in this type of conditions, what I can do is, see, ma, work done of a circle pi r square only, no? So, I can do one thing. See, ma, this distance, I can call it as a d1, and this distance, I can call it as a d2. Are you able to understand? So, this is one diameter, this is another diameter. If diameters are equal, then no problem. Directly you can write pi r square. But if diameters are not equal, then how can I calculate area of a figure? I can write this one as pi into r1 multiplied by r2. I can write like this. R square, no? R square means what? This is one r, this is another r. If both of them are equal, r1 into r2, r square. But if they are not equal, then I have to write like this. Are you able to understand? And if I know the diameters, how I can write? I can write pi. Instead of r1, I can write d1 by 2, no? Instead of r2, I can write d2 by 2. Okay, so therefore I can write pi by 4 d1 d2. So this is the equation for work done. Understood, no? So is it clear, ma? Actually, pi r square actual meaning is this one. This is the meaning of pi r square. R1 multiplied by r2. Okay. R can also be written as d by 2, half of the diameter also. No? So therefore pi by 4 multiplied by d1 into d2. Now substitute the values. Okay. So therefore, what is the equation of work done? Pi by 4 multiplied by, one diameter is nothing but 6 minus 4, no? 6 minus 4. And it is given in meter cube only, so definitely it is SI system. Multiplied by, now second d2, 10 minus 6, 10 minus 6. But it is given in atmosphere, no? 1 atmosphere is how much? Multiplied by 10 power 5 Pascal. So just to do this calculation, then that is the amount of work done by the gas or on the gas. Clear? That's it. దీనికి ఏం సంబంధం ఏమన్నా ఓకే సీమా సో what is the question? Quantity of a gas occupies initial volume V naught, initial pressure T naught, and initial temperature T naught, and initial pressure is P naught. So it expands to a volume Vma. So expansion is happening. So it means that definitely work done by the gas will be positive because expansion is there, no? So therefore, and expansion is also happening in two conditions, but constant temperature. It means first one is an isothermal process, and the second one is this isobaric process, constant pressure. So in which condition gas will do more work? That I want to calculate. First of all, let us say, clear ma? So this is pressure and this is volume. First of all, let us take this is my state. Okay ma? State A. At state A, what is the volume? Volume is V naught, temperature is T naught, and pressure is P naught. Now we are moving to higher volume, another volume at constant temperature. Okay ma? So constant temperature means what? Constant temperature means T is a constant. So PV is a constant. In ideal gas equation, we know PV is equal to nRT, no ma? If T is a constant, R is a constant, N is already a constant. It means PV is a constant. If PV is a constant, then pressure is inversely proportional to volume, no? This is which law? This is Boyle's law. So it means the first process we are doing according to Boyle's law. So if pressure is inversely proportional to volume, how can I draw the graph? This is how I have to draw the graph. Clear, Nama? And what is the direction of the graph? This should be the direction of the graph. Why? Because we are moving from lower volume to higher volume. This is V1, V naught, no? And final volume is V. This is the graph. Is it clear? Now, what is the second condition at constant pressure? At a constant pressure. So constant pressure means what? P is a constant. So therefore, volume is directly proportional to temperature in ideal gas equation. Okay, ma? So if volume is directly proportional to temperature and pressure is a constant, then how I have to draw the graph? This is the method in which I have to draw the graph, no ma? Clear, no? Why? Pressure is a constant. Pressure is a constant. Only volume is increasing. So here pressure and volume, both of them, they are not constants in first graph. Pressure is also variable, volume is also variable. But in the second graph, only volume is variable, pressure is not a variable. So this is my graph. Okay. What he is asking, in which case work done will be greater? Work done depends on what? Area. So in which graph area is greater? Second graph. That is my answer. Are you able to understand, ma? So, in the first graph, how much is the area? In the first graph, I have only this much of area. That's all, ma? This much of area is present. Okay, but in second graph, how much area I have? In second graph, I have this much amount of area, total area. Clear, no? So definitely I can say area in second graph is greater when compared to area under first graph. Okay, so if I call this area to be W1, this area to be W2. Area is nothing but work done, no? So here work done is W1, here work done is W2. So W2 is greater than W1. So work done under constant pressure process. Okay, ma? Here work done is greater. That's it. Are you able to understand, ma? Very simple. Okay. So see the next question, ma. So a sample of ideal gas is expanded to twice its original volume, ma. So original volume was how much? It was 1 meter cube. Okay. So I can say V1 is equals to 1 meter cube. Clear? So for which this is the equation of pressure which is given. Okay. And what alpha is any constant, ma? That alpha value is also given. So what is the amount of work done on the gas? That is the question. So this is important. Clear, no? So how much work is done on the gas? He is not asking work done by the gas. Adi chala careful ga chudali. Clear, no? So work is expanded. Gas is expanded. Gas is expanded means work done by the gas is positive or negative? Positive. Work done on the gas? Negative. That's all, no? So therefore, and here if I look at the pressure equation, pressure is equal to alpha into V square. Variable pressure or constant pressure? Variable pressure. So what is the equation for work done? Work done is equals to minus integration of P dV. Limits are applied from V1 to V2. Why I am writing minus, ma? Because work done on the gas we are taking. And work done on the gas is negative here. Because gas is expanding. Okay. Now just substitute. So minus integration of pressure is how much, ma? Pressure is alpha into V square dV. Limits are applied from V1 to V2. Initial volume is 1 meter cube. Final volume is 2 meter cube. Are you able to understand? So alpha is a constant, no? Take it out of integration. So minus alpha integration of V square is V cube by 3, no, ma? Or directly I will write integration of V square is how much? V cube divided by 3. Limits are applied from 1 meter cube to 2 meter cube. Okay, ma? So therefore work done on the gas is how much? It is minus alpha by 3 multiplied by, first you substitute the upper limit, ma? So 2 cube minus 1 cube. That's all, no? Limits are 2 and 1 only, no, ma? First substitute upper limit. 2 cube is 8 and 1 cube is 1 only. Okay. And now you substitute the alpha value. So alpha value is how much? See, ma, here alpha is 5 atmosphere. That also you should be very careful. Atmosphere is not the SI unit, no? Pascal, Newton per meter square is the SI unit. So therefore I will write 5 and instead of atmosphere I will write 1.01 into 10 power 5. Okay, ma? Divided by 3 multiplied by 8 minus 1. Okay, you do this total calculation, that is the amount of work done on the gas. Is it clear? That's all. Fine. చాలండి ఇంతవరకు. ఇంకా కొన్ని ప్రాబ్లమ్స్ ఉన్నాయి, అవి చెప్తే మీకు నీట్కు ఏమి సంబంధం ఉండదు, అన్ని అడ్వాన్స్డ్ క్వశ్చన్లు అవి. అంతవరకు చాలండి. అది యాదవ్ టిఫిన్ చేసినట్టు లేవు నువ్వు. కంప్లీటెడ్, మా? సో నెక్స్ట్ ఫస్ట్ లా ఆఫ్ థర్మోడైనమిక్స్ నెక్స్ట్ క్లాస్లో చదువుకుందాం. చాలండి, మీ మీద జాలీతో తొందరగా వదిలిపెట్టేస్తున్నాను నేను. అయ్యో.